Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. Learn more at OpenShift.com. Hey, it's Alex Williams of the New Stack here at OSCON, and it's Container Day at OSCON, and so we're having a day of interviews where we're talking about container platforms. And I have now with me Ryan Jarvinen, who is developer advocate and open source evangelist at Red Hat. And Ryan is going to talk to us a little bit about Kubernetes 1.3 and beyond. And I thought we would get started, Ryan, by talking a little bit about what we've seen in Kubernetes 1.2 and looking at 1.3 and beyond, and then perhaps through that you can tell us a little bit how you guys think about that with OpenShift.
Yeah. Hi, Alex. Thanks for having me on. I'm really excited about what's going on in the Kubernetes community. There's a lot of interesting extensions and kind of advancements and new features that are being added on. Some of this work is coming from Red Hat, a good amount of it actually, and so when we look at the OpenShift code base, we'll often have some of these kind of experimental features available a little bit early in our code base, and then we'll upstream those into the mainline Kubernetes code once they've been more generally accepted by the wider community. And this is kind of a model that I think we are going to see more and more contributors to Kubernetes adopting this type of model of developing extensions and then allowing people to plug them into an existing stack and then evaluate them rather than trying to change the base APIs that are what Kubernetes is composed of. Because if you modify the core APIs, you introduce
lots of problems.
Backwards compatibility breakage and other issues. And so a lot of these new features are coming in the form of extensions. So there's a lot that's been added in 1.2 and more coming along the way in the 1.3 timeline as well.
So Diane shared a presentation with me that was done by, who was that? Clayton Coleman.
Yeah, that was actually part of her OpenShift Commons series, I believe. Right. So there's a video if you want to catch the whole recap. I'm sure you could find it, I think, on the OpenShift Commons, commons.openshift.org website. And that's a great reference if you want to hear directly from Clayton, as well as there was a presentation from a Google engineer, Alan Name, also covered a lot of what's landed just recently in 1.2.
Okay, so perhaps we can focus our conversation on three themes that that Clayton talked about. I'm sure that you're thinking about as well. The support for more diverse application workloads, performance, and more comprehensive cluster management. Would that make sense?
Yeah. I think that's a great way to break it down. There's a lot that's come in specifically around performance. Let's see. Performance. Let me take a quick note here. We have performance and what are the other two categories you have?
You're talking about more diverse application workloads, and I'm wondering if you might be able to talk a little bit about that, along with the issues around performance that 1.3 and beyond tackles, and the cluster management issue.
Yeah.
And really, but whatever resonates for you as well. I mean.
I've been really excited about, I think those are great topics to go on. Let's start with those, and we'll see. One of the neat things I've heard from the core community is more clear information coming from Google on how other people can participate in extending Kubernetes.
Okay.
And I think what we've done at Red Hat and hearing this from Google really helps validate some of the efforts we've been doing the approach we've adopted to bringing these new features into Kubernetes in a way that's not breaking the core APIs and not breaking backwards compatibility. So we'll see, I guess we'll discuss a couple features that have been added. I think there's some information about third-party extensions. I'm not sure if I have a great link for that.
Sure.
But I think that's a topic I'm also pretty excited to hear about. So first, for performance, I know this is more on the after 1.3, I hear. There's definitely work on protobuf serialization as an alternative to sending all of your data in just JSON over the network, which has a significant amount of overhead just in the number of sheer parentheses alone.
Right. So tell us what that is, that serialization.
So protobuf is, I believe, was developed by, let's see, is that from Google? I'm going to have to take a quick look into that. Protobuf is kind of a protocol for serializing data, sending it in binary over the network rather than as JSON strings. And I believe it's a Google project.
Yeah, it's a language-neutral, platform-neutral, extensible mechanism, really, for serializing that structured data.
Yeah. So, and given that it's platform-neutral, hopefully this is something that, and language-neutral, this should be useful communication protocol, regardless of if you're coming from one particular app development background. You should be able to rely on this technology regardless.
So provide with some context about the performance issues that that really speaks to the need for for this improvement in 1.3 and beyond.
I think some of the issues are the sheer amount of network data that you end up with when you try to spin up 30,000 pods or so is generally what I think has been quoted as a kind of soft upper bound for Kubernetes in the 1.2 timeframe. They've been talking about having 1,000 nodes in a cluster and 30,000 pods being able to run on that 1,000 node cluster. And you could do work to see about adding more nodes or increasing the density of the pods or containers per node, but the more you ramp that up, the more you have to really conserve on the network bandwidth. Running 30,000 pods can really cause a huge spike in, several huge spikes in network data. Protobuf can really help reduce the amount of overhead on the network traffic and make the scalability much more achievable, I guess.
Okay. So with 1.3, moving into that realm, perhaps you can just talk to me, to talk to us about what are some of those, what are some of those features that we should be seeing, for instance, around application workloads. And this is kind of an interesting topic for us because one of the things that we've been seeing, at least in kind of in our own research, is how how we are starting to see kind of this next this next generation of sophistication in how you think about container orchestration environments. And this is one of the big issues, is like, how do you prioritize workloads? How do you, because there are different, there might be some, critical workloads that you want to have, put particular attention, toward, or others you may not, right?
Yeah.
Is that kind of what we're talking about here?
I think some of that is coming in a beta or experimental phase. It has already been included in 1.2. I know there's some features where, like, if you wanted to make sure you had a monitoring agent on every node that the pods could communicate with, or in order of precedent, you need this service to be first, essentially. You could use something called init containers that's going into the 1.3 series, and that'll help kind of gate the order of which service or which pod or container starts up first, and what should come up next, and give you some of that procedural or imperative programming, ordering of services. Kubernetes is primarily very much a kind of declarative syntax where you say, I need 3 or 3,000 of these pods to be running, and then you expect the platform to go do the work for you. But there's not a lot of information in the spec on what should be done first or what order it should be done in. You kind of trust that the platform is just going to figure it out and make the best decisions. And I think init containers gives you a little bit more control to say, no, actually, this actually has to come first, and then we'll have this following feature and couple pieces be added after that. So along those same lines of thinking, if you wanted a container that was just going to run once and then complete its work, its life cycle, essentially, there's a new object called jobs that's going into the 1.3 timeline. So jobs are kind of a short-lived container that could do kind of a batch processing work. Okay. And then once it's done with its work, it doesn't need the kubelet to automatically reload it or restart it. Okay. It'll be managed during the life cycle of that job, but the job is meant to run to completion and then terminate. So quite different from these standard web processes that Kubernetes is more known for managing.
This does, we do see the introduction of a whole new kind of construct, don't we?
Yeah. There's also another notion called pet sets. Pet sets, the term pet kind of goes back to the cows versus pets debate. So pet sets are much more managed to run together as a pair or a larger cluster.
Okay.
More specific.
Pet sets. I haven't heard that yet.
Yeah. I'm not sure if that naming will stick. We'll see. I know that's something that I've been hearing from our engineering team. I've been hearing about it since February or so. So I imagined it was going to be in the 1.2 timeline, but it looks like it's 1.3 or later.
Okay. So with 1.3 now, we've talked a little bit about performance. We've talked a little bit about workloads. Mm-hmm. What are some of the other topics of interest to you? etcd is a core part of Kubernetes. Any changes there at all?
There's a lot of changes in etcd3. I'm not familiar enough with what specifically is coming down the line on those changes. I know there's going to need to be a certain amount of work to adapt the etcd2 code to etcd3. I believe.
What are some of the overarching, complexities that is requiring etcd to become something that supports better performance, that allows for these diversity of application workloads and other matters?
That is a great question, and I'm not sure if I'm the best one to answer it,
That's all right.
unfortunately.
Sure.
I know there's a lot of work being done around scalability,
Right.
particularly
That's
in the
really it, isn't it?
etcd3. Yeah, I think it's mostly scalability issues. I don't think that is necessarily the main blocker for scaling Kubernetes.
Right.
I know OpenShift has a large OpenShift online hosted deployment,
Right.
and we'd love to migrate every one of our millions of users over to Kubernetes today. But today Kubernetes doesn't seem to scale up to handle our entire our entire user base that we have on OpenShift Online. So we're definitely working on a variety of scalability issues in order to help migrate that community. We're also looking into the clustering of Kubernetes. There's a Kubernetes project that is really focusing around.
Tell us about that.
So Kubernetes is really meant to allow you to run multiple Kubernetes clusters and have some cross-cluster management, I guess.
Okay.
I guess if you were able to run existing Kubernetes cluster to its maximum, say 1,000 nodes,
Right.
Do you want to have? Is it a good idea to have more than 1,000 nodes all with the same administrative command line tool where, one mistyped command you might lose your, 1,000 nodes might be a good limit to the total amount of damage, right?
Yeah.
So
Yeah.
if you can segment,
You might launch a rocket ship and not even know it.
you can segment these Kubernetes clusters and have Kubernetes provide a overarching interface to each of these kind of. It's almost like sharding your database or splitting it into different
Like sharding
regions.
Kubernetes?
Yeah, in a
Interesting.
way, yeah. So and I think from what I understand, there's some work to provide at the Kubernetes level, there would be a Kubernetes-like API, if I understand it correctly, and I think they're working on having some API endpoints available in Kubernetes, but not necessarily everything you'd get at the lower level direct Kubernetes access.
Okay, so that does speak to cluster management, doesn't it?
Yeah. That's definitely one of the more advanced kind of cluster management features that's being added on.
Okay, great. So we've touched on performance, we've touched on application workloads, we've touched on cluster management. Any other major kind of topics we should be discussing before we finish up here?
Yeah, I guess there's a lot of great stuff, a lot of changes that have come in the 1.2 timeline, and even more changes to come. I guess to wrap it up, there's a couple things OpenShift has upstreamed that are useful for these communities. So I know there was a conversion before. There was an object called a replication controller that's being replaced by replica sets. OpenShift or the Red Hat team has.
So tell us about that, with the replication controller being replaced by replication sets.
All I know is that that's slated for, that they're deprecating the old replication controllers and it's being renamed. That seems kind of like a break in API compatibility almost to me, right? You're renaming a core resource or a core asset. And so in order to limit the amount of damage caused by swapping out this one resource underneath you, I think what I've heard is the Red Hat team has a conversion between replication controllers and replica sets that has been upstreamed that hopefully will help ease that pain and give people some time to migrate on to replica sets. By the time 1.3 comes out, they'll have
What is the advantage of these new replica sets?
I'm not sure. I know it works similarly. It has it manages the scale of a given pod asset, but I'm not sure about the specific details of how they've modified this.
It's a next generation replication controller, which makes sense, right?
Yeah.
And I'm just reading from the Kubernetes page. It supports the new set-based selector requirements.
And it's based on the page you pulled up there. It looks like it has a little bit more awareness maybe of the new deployments feature, or does some relation to deployments. What we have in OpenShift is something called a deployment config. And I know there's a new object in Kubernetes called deployments. So I'm also, just like the replica controller and replica sets, and how there's some transitionary effort that needs to be done there, I'm a little bit anxious to see what we do within Red Hat, how quickly we can move to the kind of new anointed standard of deployments. And
well, this relates to So what I'm reading here, this really relates to rolling updates.
Yeah. This is the way deployments and Red Hat's deployment config, they both work by creating a new replica set or replication controller each time that you have a major change to your image. So you could then say, I'd like to update this group of 10 services or pods, and this is how I would like to have them updated. We want to do a rolling update, or we want to do a blue-green or a A/B deploy, or you could have, I know in our deployment configs, there's different strategies you can define for how that deployment should roll out across the cluster. So I think replica set and deployments are meant to provide some of that functionality. I don't think it has everything we need in order for us to just flip a switch and move directly to Kubernetes deployments today.
So perhaps we can conclude with talking about how Red Hat treats these upgrades, in OpenShift.
So Red Hat does a lot of upgrades for the cluster, the pods.
How do you guys roll out? So like as Kubernetes 1.3, Kubernetes 1.3 will come out in June, and then there'll be updates coming in after that, right? So as these updates shift, kind of move with the updates. How are you managing that? Do you bring all the new features in at once?
As far as the code base is concerned, well, a lot of these, in order to add new features effectively without breaking the core APIs, whenever possible, you want to develop them as third-party extensions, and have these features be easily pluggable into a kind of a neutral vanilla Kubernetes environment. This allows collaborators or potential contributors to really develop something on their own and hand it off to other community members, have them evaluate it. So I think there's a new feature called third-party extensions that is being added as well, that actually gives you a pretty clear path for making these contributions and adding new features. I know for our timeline, we were initially trying to get our OpenShift Origin 1.2 to have the same release date as Kubernetes 1.2. But then there's always a mad dash on the last code cutoff day, or the release day, to make sure everything made it in that was meant to make it in, and it's really difficult to do a same-day release. And so I think we've decided to take a slightly different approach. I think our new plan is to try to do a OpenShift release that trails the mainline Kubernetes release by about 2 weeks.
Okay.
We'll still have some independent features that are upstream or not not available quite yet that you can evaluate by downloading OpenShift.
Okay.
And hopefully you'll see those features appear in new features or new versions of the main Kubernetes releases. The 1.3 stuff is looking really exciting. I know we already have on our GitHub releases page, there's already a tag for the 1.3 alpha series, and we've got a release candidate for our 1.2 release of OpenShift Origin. Couple release candidates that have been published. So I'm expecting our 1.2 OpenShift Origin to be available very soon. And that has a lot of really cool features that you'd be able to play around with. I know deployments are available, even though we still use deployment configs.
Right.
So I get a chance as a developer to try the differences and learn, what are the trade-offs, and
that's cool.
Yeah, it's really neat to see some of these new features showing up so quickly.
Well, great. Well, Kubernetes really is really gained such momentum, and OpenShift made such a smart move to really become so aligned with it. It makes so much sense. That community is growing just by leaps and bounds, and it seems to be really exemplified in the OpenShift Commons too, with what you guys are saying.
Yeah, I think it's the OpenShift Commons is a great resource. We have a lot of interesting. The Commons briefing page particularly has a lot of great screencasts and demos and interviews with core developers and contributors and external folks as well, all coming through. So it's a great resource. Yeah, I definitely recommend it.
Well, Ryan, thank you so much for taking some time to talk. I really appreciate it.
Yeah.
Learned a bit here. Good studying, for what's coming up, and we look forward to keeping in touch.
All right, cool. Thank you.
Thanks, Ryan.
Yeah, you bet.
Red Hat OpenShift is the sponsor for our container platform coverage from OSCON in Austin, Texas. OpenShift reaches across open source communities to collaborate for healthy upstream development. The goal? Ensure the support for features and functionalities that end users require across the overall ecosystem. Learn more at OpenShift.com.